Welcome to today's deep dive. I am your host.
And I'm your expert guide for today's exploration.
So to kick things off, I want you to imagine something for a second. Just imagine you are walking into a factory that is so sprawling, you literally can't even see the other end of it.
Right, like the ceiling just disappears into this haze of artificial light.
Exactly. And you feel this steady, rhythmic hum vibrating right to the soles of your shoes. And then that hum is punctuated by the heavy, just earth-shaking thud of 5,000-ton stamping machinery.
It is a sensory overload, for sure.
Oh, absolutely. Now, imagine that a brand new, fully finished car rolls off that production line every minute or two, like every 60 seconds.
Yeah, that speed is just staggering.
Right, and here's the kicker. Almost no human hands have touched it. You got thousands of industrial robots moving in perfect synchronization, showering sparks everywhere.
Maneuvering 2-ton chassis with surgical precision.
Yeah, and almost every single component making up that car, from the heavy electric battery pack to the tiny microchips, is manufactured just a few miles down the road.
Which sounds entirely like science fiction, but it is happening right now.
Okay, let's unpack this. Because we aren't just talking about building one cool futuristic building here. We are dissecting an entire global shift in how things are made.
Yes, a massive shift.
So today we are pulling from the deep dive research in The Blueprint of Giants, rebuilding the global automotive ecosystem. Plus, we've got some incredible video source material analyzing China's highly automated mega factories.
And, the core mission for you listening to us today is to explore one really fundamental question. Is it actually possible to recreate this colossal, hyper-efficient manufacturing system right here in America?
It really is the question defining the modern industrial era, isn't it?
It absolutely is, because what you see on that assembly line, the robots, the speed, the gleaming new cars, is really only the tip of a massive geopolitical and economic iceberg.
Right.
So to answer if America can rebuild it, we first have to peel back the layers and understand the sheer depth of what it actually is.
Right, before we can even debate bringing this ecosystem here, we need to take you inside these Chinese megafactories to see what we are actually dealing with. And the scale is just, mind-boggling.
It operates at a velocity that traditional manufacturing just struggles to even comprehend.
Yeah, we are talking about a continuous, almost non-stop production process. But it isn't just about having a lot of machines, is it?
No, not at all. It's the intelligence built into the machines themselves. You start with these gigantic automated stamping presses.
Oh, right. The ones shaping the metal.
Exactly. But they aren't just blindly molding raw steel and aluminum. They are equipped with these incredible force sensors that can detect microscopic variations in the tensile strength of the metal.
Wait, really? So it adjusts while it's stamping?
Yes, adjusting the stamping pressure on the fly so the metal doesn't tear. And then from there, the chassis moves to the robotic welding lines. Picture hundreds of mechanical arms showering sparks, welding the whole frame together.
And what really struck me in the source material is the precision of it all. Like, humans are acting more like conductors than laborers. And the technology driving this is just wild.
It really is a massive leap forward.
They're using machine vision and AI inspection algorithms. So instead of a human eyeing a weld to see if it looks right, a laser measurement system scans the joint in milliseconds.
Right, comparing a real-time 3D scan against a perfect digital CAD model.
Yeah, and if the metal is off by a single millimeter, the AI instantly recalculates the angle for the next robotic arm down the line, to compensate for that exact variance.
Which is how you achieve perfectly uniform panel gaps on thousands of cars a day, all without stopping the line to recalibrate.
It is like a perfectly choreographed mechanical ballet.
Well, actually, when you look at the logistics inside the building itself, I'd say it's more like a living organism. You have these autonomous guided vehicles, or AGVs.
Oh yeah, the AGVs are fascinating.
They are basically these low-profile robotic sleds zipping around the floor completely autonomously.
After reading the sources, I really like the analogy of a circulatory system for this. Like, the factory is the living body, the robotic arms are the organs, and those AGVs act like red blood cells.
That circulatory system analogy is spot on.
Because they are constantly carrying the exact nutrients like the right parts to the organs at the precise second the body needs them to survive. They pull parts from automated warehouses and just navigate this chaotic floor without ever colliding.
And just like a biological system, it is constantly monitoring its own health. Because the vulnerability of a system moving this fast is that a single bottleneck creates a catastrophic cascading failure.
Right, if one red blood cell drops its payload, the whole body goes into shock.
Exactly. That is why they rely so heavily on predictive AI.
I have to push back a little here, though. I mean, how does a system this complex run continuously without falling apart? Eventually a motor burns out, right?
Oh, of course, physical degradation is inevitable. But the system isn't just building cars. It is constantly analyzing the vibration frequencies and the temperature outputs of its own robotic motors.
Oh, wow. So it knows when it's going to break.
Yes, the AI predicts when a welding robot's joint will fail, sometimes 3 weeks before it actually breaks down.
That is insane.
It allows technicians to swap the part during a scheduled 15-minute shift change, rather than suffering an unplanned 4-hour outage. But to your earlier point, the real magic here isn't just what is happening inside the four walls of the factory.
Right. It is what surrounds it, the geography of it all.
What's fascinating here is that a hyper-fast automated factory is entirely useless if it has to sit idle for 3 weeks waiting on a cargo ship to cross the Pacific with a batch of semiconductor chips.
Yeah, that makes total sense.
So over the last 2 decades, China didn't just build factories, they poured immense government infrastructure funding into building complete geographically condensed supply chains.
And for anyone picturing a corporate buzzword when we say supply chains, what we really mean here is vertical integration.
Yes, deep vertical integration.
This isn't just a company buying parts from a catalog. They are owning the entire ladder. You've got the battery ecosystem, the processing facilities for the rare earth magnets used in the motors, the steel foundries.
The electronic suppliers, even the facilities that package the semiconductors, and crucially, all of it is physically clustered together.
Right.
You have third-party suppliers and wholly owned subsidiaries located literally minutes away from the final assembly plants. It's this dense industrial biome.
Which brings in some incredibly powerful economic forces, right?
Primarily economies of scale and just unparalleled logistical efficiency. When your supplier is down the street, your shipping costs don't just drop, they evaporate entirely.
And you don't need to rent massive warehouses to store 3 months of inventory to hedge against shipping delays. It is just-in-time manufacturing taken to the absolute extreme.
Exactly. And it is all connected by world-class logistics infrastructure. We are talking about automated ports, a network of freshly paved highways specifically routed for industrial transport, and high-speed rail networks. This efficiency saves these manufacturers billions of dollars annually. It is a structural advantage built into the very concrete of the region, not just a clever business model.
Wait, so it's not just about erecting a big building full of robots. It's like trying to build an entire city where every single resident's only job is to supply that one factory.
That is the exact reality of it. You are building a metropolis dedicated to a single final product. And this perfect storm of factory efficiency and unparalleled supplier density has birthed a completely new breed of globally competitive automakers.
The EV titans. We absolutely have to talk about these companies because if you're listening to this and you're hoping to buy an EV in the next couple of years, this geopolitical tug of war is the exact reason your options are changing.
It is completely reshaping the consumer market.
Yeah. The source material outlines major Chinese players completely dominating the global market right now. You've got BYD, Geely, Chery, SAIC, GWM, XPeng, NIO, and Li Auto.
It is a massive roster of heavy hitters.
It is. But let's zoom in on BYD for a second, because their story is the perfect example of why this ecosystem works.
BYD is the quintessential case study here, because they didn't actually start out as a car company.
Right. They started out in the 1990s making rechargeable batteries for early Motorola and Nokia cell phones.
And that pivot is the defining insight. Because they started as a battery company, they don't view an electric vehicle as just a metal chassis that you awkwardly shove a battery into.
No, they view the car as a highly sophisticated battery on wheels.
Precisely. And in the electric vehicle market, the battery dictates everything. It dictates range, performance, safety, and most importantly, cost.
Yeah, cost is huge.
China's dominance in battery manufacturing is their single biggest competitive advantage. But it goes deeper than just building batteries. It is the specific chemistry they chose to master.
This is where it gets highly technical, but it's incredibly important. We are talking about LFP batteries versus NMC batteries, right?
Yes. So for years, Western automakers heavily favored NMC nickel manganese cobalt batteries because they offer slightly higher energy density, meaning a bit more range.
Okay, that makes sense.
But Chinese automakers, led by companies like BYD, doubled down on LFP, which stands for lithium iron phosphate.
And what's the advantage there?
Well, LFP batteries are significantly cheaper to produce. They last for thousands of more charge cycles, they are far less prone to catching fire, and crucially, they don't require cobalt, which is expensive and ethically fraught to mine.
Oh, wow. So by mastering that LFP chemistry at a massive scale, these companies fundamentally lowered the floor on how much an electric car costs to build.
Exactly. They achieved a massive structural cost advantage.
Here's where it gets really interesting. Because of that cost advantage, they aren't just churning out cheap, bare-bones cars. They are building incredibly smart cars.
The deep software integration in these vehicles is staggering.
Yeah, they're operating more like nimble Silicon Valley tech startups than the sluggish legacy automakers you and I might be used to.
That agility is their second major weapon. Because of their software-first approach, their rapid product development cycles are just astonishing. A traditional legacy automaker might take 4 to 5 years to design, test, and manufacture a new car model.
Right.
But some of these Chinese EV titans are doing it in 18 months.
18 months. Because I guess when your suppliers are in the same city, if you need to tweak the design of a motor housing, you just send the file over and you have a physical prototype on your desk by the afternoon.
Rather than waiting 3 weeks for a shipment across an ocean.
Exactly.
That is wild.
And because of those low manufacturing costs and hyperlocal supply chains, they can engage in highly aggressive pricing globally. They're
Right.
bringing advanced technology like LiDAR integration and autonomous driving features to market at price points that Western competitors are currently struggling to even comprehend, let alone match.
And because these companies are dropping prices so aggressively and innovating so fast, it has completely disrupted the American market.
Without a doubt. And that disruption has forced this from being just an economic issue into a fiercely debated political one. Watching this explosive, hyper-efficient growth overseas has triggered a massive reaction here in the United States.
It has become a central focus of American political and economic discourse. The paradigm is shifting rapidly.
Yeah, we are seeing this play out in real time across the political spectrum. Based on the sources we're analyzing, President Donald Trump has repeatedly and forcefully argued for a sweeping push toward domestic auto manufacturing.
Yes, it's a very prominent talking point.
The mechanisms being debated to counter this overseas dominance are heavy tariffs to protect American markets, massive federal incentives to build locally, and a broad, sweeping strategy of reshoring, essentially forcing the factories to come back home.
If we connect this to the bigger picture, this debate about reshoring auto manufacturing is really a proxy for one of the defining shifts of our time.
Which is
The transition from globalization to localization. For the last 40 years, the global economy was built on a simple premise. You manufacture wherever labor and materials are cheapest, regardless of borders.
right. But the pandemic violently exposed the fragility of stretching supply chains across oceans. I mean, a boat gets stuck in a canal or a factory locks down across the world, and suddenly you can't buy a car in Ohio because it's missing one 50-cent microchip.
Precisely. Now, the paradigm is shifting to manufacturing wherever it is most secure and strategically advantageous. It's a national security concern.
Yeah, that makes sense.
There is a realization that reducing dependence on foreign supply chains for critical technologies like high-capacity batteries and semiconductors is no longer just about protecting local jobs. It is a strategic necessity for the functioning of the country.
Okay, so the political desire is clearly there, and the security strategy makes sense on paper. But we need a reality check. What are the actual on-the-ground hurdles to reshoring this in the U.S.? Because based on everything we just discussed about those integrated industrial biomes, you can't just pass a law, flip a switch, and make it happen.
You absolutely cannot. The challenges are immense, they are deeply entrenched, and they broadly fall into 3 categories: labor, cost, and the supply chain itself.
Let's start with labor.
Well, the United States is currently facing a severe shortage of skilled manufacturing workers. And we aren't just talking about assembly line workers, we are talking about a critical deficit in mechatronics engineers.
Mechatronics. So people who understand mechanical engineering, electronics, and software coding all at the same time.
Yes. To run a highly automated factory, you need thousands of technicians who can troubleshoot a robotic arm's physical gears, recalibrate its optical sensors, and rewrite its AI predictive maintenance code on the fly.
That is a very specific skill set.
It is. Furthermore, the U.S. has an aging workforce in the traditional trades electricians, pipe fitters, millwrights, the people you actually need to build and maintain the physical factories.
Right, because you can have all the automated AGVs in the world, but if you don't have the engineers to program the traffic flow or the technicians to fix the laser sensors when they drift, the whole multi-billion-dollar factory just grinds to a halt.
Exactly. Then there is the cost disparity. There is an undeniable contrast between Chinese factory wages and U.S. labor costs.
Sure.
But it's not just the hourly wage you take home. In the U.S., manufacturers carry the added weight of significant healthcare costs, higher commercial insurance premiums, stricter environmental compliance codes, and a highly complex corporate tax structure.
And all of that overhead just gets baked into the final sticker price of every vehicle rolling off the line.
Precisely. And then there's the third category, which goes back to our city analogy, the supply chain. You can't just build a factory, you need the ecosystem.
Right.
Which brings us to the most sobering metric of all, which is time. The timelines required here are daunting. With enough capital, building a single state-of-the-art final assembly factory might take 2 to 4 years.
Okay, 2 to 4 years isn't terrible.
No, but building a mature, dense supplier ecosystem, that takes 10 to 20 years of compounding growth.
Wow. But I guess that makes total sense when you think about the history of American manufacturing. I mean, Detroit didn't become the Motor City in 2 years.
Exactly.
It took a generation to build that dense web of steel suppliers, glass makers, and parts manufacturers around the big three automakers. You can't just manifest that overnight.
No, you can't. To rebuild an entirely new EV ecosystem from scratch, to rival the scale and efficiency of what China has spent the last 30 years cultivating, could realistically take decades.
Decades.
And the capital required is astronomical. We are talking hundreds of billions of dollars.
Easily.
It requires sustained public-private synergy. You see the beginnings of this with state-level tax incentives, the GPS Act, which is pouring billions into bringing semiconductor manufacturing back to U.S. soil, and the Inflation Reduction Act to spur domestic battery production.
Right, but passing legislation is really just step one.
Yes, there is a massive lag time between signing a bill and actually having a functional local supplier network turning out raw materials.
So building the massive factory is actually the easy part. It's like buying a multi-million-dollar state-of-the-art commercial kitchen, outfitting it with the best ovens and the sharpest knives on the planet.
I like this analogy.
But you have no grocery stores within 500 miles, you have no farmers growing the ingredients, and you have a severe shortage of chefs who actually know how to cook the recipes.
That is a very apt way to look at it. You possess the hardware for production, but you entirely lack the ecosystem for sustenance.
So, given these monumental timelines, the specialized labor shortages, the regulatory costs, what are America's actual chances here? And more importantly, what does this all mean for you?
That's the big question.
If you're listening to this and you're thinking about the future of transportation, how does this actually play out?
Well, let's look at the balanced arguments presented in the research. For America, the case isn't hopeless by any stretch. The U.S. still possesses world-class advanced engineering capabilities.
Right. We have deep aerospace expertise, for instance.
Exactly, which translates remarkably well to complex, high-tolerance manufacturing. The U.S. also boasts some of the strongest research universities on the planet, a deeply ingrained culture of rapid innovation, and historically, America has been the undisputed leader in software development and artificial intelligence.
But the argument against America catching up directly in this specific hardware game is incredibly tough to ignore.
It is. China's current overwhelming scale advantage, their hyper-dense supplier networks, their 3 decades of compounding manufacturing experience, their structurally lower costs, and their fully mature battery ecosystem make direct toe-to-toe competition in physical hardware manufacturing incredibly difficult.
This raises an important question. Should America even try to compete directly on this massive hardware-focused scale, or should it specialize?
That is the pivotal debate unfolding right now. Should the U.S. spend trillions of dollars and decades of time trying to recreate the physical manufacturing dominance that China already possesses? Or should it leapfrog to the next paradigm and specialize in higher value design and software integration?
And for you, the consumer, this global competition dictates everything. I mean, it ultimately impacts car prices because scale and logistical efficiency are what drive prices down. It
Absolutely.
affects availability, the speed of technological innovation, and how quickly electric vehicles are adopted globally. When you have this intense competition between American, European, and Chinese automakers, it forces everyone to iterate faster. You get better batteries, smarter software, and safer cars.
When multiple global regions are vying for technological supremacy, the friction of that competition usually benefits the end consumer with more advanced products at lower price points.
So to wrap this all up, the big takeaway from our deep dive today isn't just about cool robots and laser-guided assembly lines. It's the realization that China didn't become this industrial powerhouse overnight.
No, it took immense planning.
Yeah, it took decades of meticulous planning, staggering government investment, and obsessive infrastructure development to build an industrial biome. The real question isn't if America can build a factory. Of course it can. The question is if it can rebuild an ecosystem, and if that is even the right goal in a rapidly changing global economy.
I want to leave you with a final thought to mull over, building on that idea of leapfrogging the current paradigm. What if America's best move isn't trying to rebuild the supply chain for the physical hardware of the car at all?
Oh, interesting.
What if the strategic goal should be entirely dominating the software, the self-driving artificial intelligence, and the operating systems that actually drive the vehicle?
So the hardware takes a backseat.
Exactly. If the physical metal chassis of a car eventually becomes a cheap, imported, commoditized shell, the true mega factory of the future might not be a building full of welding robots and stamping presses. It might be a server farm full of code.
Wow, the car just becomes the hardware case for the real product. The software is the engine. If you enjoyed this deep dive, follow us for more explorations into the industry shaping our future. And I want you to think about it. Do you believe America can realistically rebuild this manufacturing machine from the ground up? Or has we already entered a new era?